Hello and welcome to ECMath. Today we're going to explore all of the different ways that you might combine two functions. Before watching this video, you should probably be familiar with function notation, be familiar with working with polynomials, fractions, division of functions, and how to find the domains of rational and radical functions. So go back and check on those things if you need to, and then come back here. In this video, we're going to add, subtract, multiply, and divide functions. We're going to compose two functions. We're going to find the domains of all of those things. And we're going to explain how the notation works for all of this various stuff. So the first thing that you might be asked to do is just make simple combinations of two functions. So say that we have f of x equal to x squared minus 2x and g of x equal to x minus 2. These are pretty simple polynomial functions. The first thing you might be asked to do is find the sum of these functions. So the notation for that would be f plus g of x. Be careful or notice what's going on with the notation. This is not a distributive property. There's no like missing x here. This is just how it's written. And when it's written this way, what it's asking you to do is take the equation of f of x and add it to the equation for g of x. I'm going to do that here and see what we get. So in this case, there were two like terms to combine, nothing else combined. We just added the two equations and simplified. You might also be asked to find the difference of two functions. That will be written as f minus g of x. If you see this on the page, what it's asking you to do is f of x, the equation for f of x, minus the equation for g of x. When you're doing a difference of functions, make sure that you put the second function in grouping because you're taking away the whole function, and distribute the negative to all of the terms of that second function. You might also be asked to do the product of two functions. That will be written as fg of x. And this is asking you to do the equation for f of x times the equation for g of x. If you get into the situation where you have two terms in each of the functions, you do have to use the distributive property. Distribute all the terms of the first to all the terms of the second. I'm going to carry that out now and see what we get. So when you're multiplying two functions, be mindful that you may have to distribute, but it's not really too bad. Then the last thing you might be asked to do is the quotient of the two functions, which is the division. So f over g of x is how this will be written. And if you see that, it's asking you to do the equation for f of x divided by the equation for g of x. We can set this up. I want to make a quick note, once I've set this up, that we do have a restricted value. So when you're doing quotients, you also need g of x to not be 0, just to create sort of the correct domain. So in this case, what would make g of x 0 is if x is equal to 2. So I need to set the restriction that x should not equal 2. From there, I can simplify. It's just like finding excluded values. So from there, you can simplify, factor the top, and those will reduce out, and you just get x, but I always like to say x with the restriction that x should not equal 2. So that's how you compute the quotient of two functions. So sum, difference, product, and quotient are not so bad. It's just common everyday algebra. the things to be mindful of are the actual notation, what you're asked to do with that notation: f plus g, f minus g, fg, and f over g. It's especially this fg that can be confusing to people because it doesn't look like there's an operation in there. So remember, when you see that fg, it's talking about multiplication of the two functions. In the last example, the functions we were working with were just polynomials, and so other than the division problem, there was nothing restricted in the domains. Everything worked out just fine. You could input every x, but that won't always be the case. So here's a key idea, and you should write this down. The domain of a combination of that one of those four types is the intersection of the two domains. And this is the intersection mathematically, like in a Venn diagram, the shaded middle piece. That's what we mean by intersection here. So say that I want to compute the domain of the following of these two functions in two different combinations. So I have square root of x plus 3 and square root of 2 minus x. So first I could write what f plus g of x is. In this case, it's square root of x plus 3 plus the square root of 2 minus x. Quick note, you cannot combine these any further. There's no rule about adding roots and combining what's underneath. That rule is for multiplication that you're probably thinking of. So this is actually it for f plus g. To find the domain of f plus g, though, make some space here, you need to separately list the domains of f and g. So the domain of f, we'll say f of x, which is equal to the square root of x plus 3, you can find by setting x plus 3 greater than or equal to 0 and solving, and you get x needs to be greater than or equal to negative 3. Then I also need to find the domain of g, square root of 2 minus x. I can find that domain by doing the same thing. I can take 2 minus x, make that greater than or equal to 0, and solve. In this case, to solve, I'll add x to both sides. And I get 2 is greater than or equal to x, which we could think about as saying x is less than or equal to 2. I'm going to go ahead and sketch both of these inequalities on this number line. So for the domain of f, that is x greater than or equal to negative 3. So you could do an open circle or a bracket and shade, all the way out to infinity. And for the domain of g, x needs to be less than 2. So you could do a closed circle or bracket. I said open circle earlier. That was wrong. Closed circles on both of them. You could shade all the way out to infinity. Negative infinity, I should say. Now, when we're computing the domain of the sum, both of these parts need to be satisfied. If I have x is equal to, say, 4, and I plug in x equals 4, well, I'm doing 4 plus 3, that's okay, but I'm doing also the square root of 2 minus 4. That gives me an imaginary number. So 4, for example, can't be in the domain. The only things in the domain that are allowable are things that are in the intersection or overlap of these two shaded regions. So in this case, that would be the interval negative 3 up to 2. So the domain of f plus g would be the interval negative 3 to 2, or you could give the inequality like that. But it's the mathematical intersection of the two domains when you do this. Up here in the top is what we mean when we say, intersection of two domains. We've done problems like this before. I think it was in section P.9, maybe. It's a nice little thing to recognize. For the second half of the example, it's asking, same functions, it's asking us to compute the domain of f over g. So first, what would f over g be? Well, it would be the quotient of the two equations. You can put these under a single root if you want. I think that would be nice, in fact. But when you compute the domain, you're going to use the same idea. We're actually kind of thinking about this when we think about the domain. And so it's still going to be the intersection of the two domains, the answer from above. But additionally, we need this whole term to not equal 0. We can't have g of x equals 0. So where would square root of 2 minus x equal 0? That would happen when 2 minus x was equal to 0, which would happen when x was equal to 2. So restricted from the domain, we should actually have x not equal to 2. So I just went up and got the graph from the last example, but I need x to not equal 2 in this case, so I am going to replace the closed circle that I had at 2 with an open circle, and I'm going to replace the bracket I had on 2 with the parentheses. When I compute the intersection, it's going to be the same thing. I'll have a bracket here, but I'll just have a parentheses on that end. So it's as a final domain, it should be -3 up to 2 with a paren to exclude 2, because we now need 2 to not equal 0 in addition to x being less than 2. So the domain would be -3 up to 2, or -3 less than or equal to x less than, strictly less than 2. And the key idea here, just with the division, is when finding the domain of f over g specifically, the domain should also exclude any values that make g equal to 0, in addition to being the mathematical intersection of the two domains of f and g. I'm going to end this video right here, and I'll see you immediately in the following video to talk about how you could compose or combine two functions by plugging them into one another. That's next.